This is physics A-levels, October-November 2019, and paper variant is 11. So let's solve this paper. Question number 1. For which quantity is the magnitude of a reasonable estimate? Frequency of a radio wave is up to gigahertz, so that's not correct. Mass of an atom is to the order of 10 raised to the power negative 24. That's also not correct. It's 500 micrograms. The Young modulus of a metal 500 kilopascals. That's roughly to order of gigapascals. So that's also not correct. So D is the wavelength of green light. It's 500 nanometers. So that's a reasonable estimate. So D is the correct answer. Question number 2 says that speed of a wave in deep water depends on its wavelength L and acceleration of free fall G. What is a possible equation for the speed V of the wave? Part A says V equals square root GL over 2 pi. In this, 2 pi is a constant, so what we can do is evaluate the units of GL. G is acceleration, and acceleration units are meter per second square, and L is the length, which is meters. So meter per second square into meter forms meter square by second square. Taking the square root of these units, because there's a square root here, gives meters per second. So part A is fortunately the correct answer. So question number 3. The diagram shows two vectors x and y drawn to scale. If x equals y minus z, which diagram best represents the vector z? So the resultant vector is x and y is this vector, minus z is this vector. So A shows which best represents the vector z. So this vector z would be in the opposite direction of negative v, so this would be A. A is the correct answer. Question number 4. A student intends to measure accurately the diameter of a wire known to be approximately 1 millimeter and the internal diameter of a pipe known to be approximately 2 centimeter. What are the most appropriate instruments to use to make these measurements? You must know that for micrometer, it measures up to millimeters and pipe measures up to centimeters. So you can say that the wire will measure, for wire we can use micrometer, and for pipe we can use calipers. So C, 4C is the appropriate answer. Question number 5 is that the power P dissipated in a resistor of a resistance S is calculated using the expression P equals V square over R, where V is the potential difference across the resistor. The percentage uncertainty in V is 5% and R is 2%. What is the percentage uncertainty in P? So what we can do is P equals V square over R. So percentage uncertainties gets added up when there is division or multiplication. So, and if there is power, the 2 V square, so 2 into percentage uncertainty of voltage, which is 5, plus percentage uncertainty of R, which is 2, so this becomes 12. So D is the correct answer. Question number 6 says that the velocity time graph for an object of mass 2.5 kg is shown. What is the resultant force acting on the object? We simply have to apply F equals ma, and acceleration can be found from the velocity time graph. 12 minus 4 divided by 15 minus 0, that's 3 by 5, multiplied by 2.5, which makes up 1.5 newtons. So question number 6, the answer is C. Question number 7 says, which statement follows directly from Newton's first law? A body remains at constant velocity unless acted upon by resultant force. That's Newton's first law, actually. So A is the answer. Let's see the other options. B says a satellite in circular motion about the Earth has a constant velocity. That is not Newton's first law. A water drop leaving a spinning umbrella travels at constant velocity. That is not constant. That is not Newton's first law. The force acting on an object is equal to the change in momentum. That is Newton's second law. So A is the answer. Question number 8. A resultant force causes an object to accelerate. What is equal to the resultant force? The acceleration of the object per unit mass, that's acceleration over mass. The force is basically m into a. So acceleration over mass is nothing. It's not force. So B is change in kinetic energy per unit time. Energy per unit time is basically power. Part C, it's change in momentum of the object per unit time. That's basically force, because rate of change of momentum is force. So C is the correct answer. D is the change in velocity of the object per unit time. Velocity per unit time is basically acceleration. So C is the appropriate answer. Question number 9. A skydiver falls from an aircraft that is moving horizontally. The vertical component of the velocity of the skydiver is v. The vertical component of the acceleration of the skydiver is a. Which row describes v and a during the first few seconds after the skydiver leaves the aircraft? During the first few seconds, the velocity would increase, and after it would decrease. And acceleration would initially decrease, and after that it would become 0, because the object would attain terminal velocity. So D is the appropriate answer. Question number 10 says two gliders are traveling towards each other on a horizontal air track. Glider P has mass 0.3 kg and is moving with constant speed of 1.2 meters per second. Glider Q has mass 0.6 kg and is moving with a constant speed of 1.8 meters per second. The glider has a perfectly elastic collision. What are the speeds of the two gliders after the collision? So basically they have perfectly elastic collision, so relative speed of approach equals relative speed of separation. The formula is UA plus UB equals VA plus VB. We have the values 1.2 plus 1.8 is 3. So 3 is the relative speed of approach. Now seeing this table, we have to see that the relative speed of separation must also equal 3. So 2.8 plus 0.2, C is the correct answer. This adds up to 3. The rest are not equal to 3 if we add them up. So C is the correct answer. Question number 11 says that an object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. So density is basically mass over volume, and weight is mass into gravity. So mass becomes weight over gravity. So from here we can deduce that mass is proportional to weight and density is proportional to weight. So what we can do is we can say that if the density increases, the weight increases. Okay, so density of oil would be weight minus Q, W minus Q divided by, and density of water would be W weight minus P. So D is the appropriate answer. Question number 12 says which diagram shows a couple? The condition for couple are that the forces must be opposite, they must be parallel, and they must not coincide. Part A is the appropriate answer because they are opposite, they are parallel, and they are not coinciding. B, they are not opposite, they are in the same direction. C, they are coinciding. See, this force and this force is coinciding. D, there is not a second force, so A is the appropriate answer. Question number 13 is an object of weight 120 Newton is supported in equilibrium by two strings as shown, T1 and T2. What is the tension T1 in the left hand string? We have to find the tension T1. So what simply we have to do is divide this T1 and T2 and this 120 Newton into vertical and horizontal forces and resolve them up. Vertical forces equals 120 minus 120 equals T1 sine 70 plus T2 sine 20, and the horizontal forces T2 cos 20 equals T1 cos 70. We can find the ratio T2 over T1 from here and substitute it in equation 1 to find T1 equals 113 Newton. In a large container, question number 14, in a large container in an oil refinery, 3 oils of different densities are mixed. no chemical activity occurs. The mixture consists of 1200 kilograms of oil of density 1100 kilogram per meter cube, 1500 kg oil of density 860 kg per meter cube, 4000 kg oil of density 910 kilogram per meter cube. We have to find the density of the mixture. Density is basically mass over volume. The total mass is 1200 plus 1500 plus 4000, and to find the total volume can be found by dividing the mass by density. So we have the mass, we have the density, just divide them up to get 1.09. 1200 divided by 1100, 1500 divided by 860 is 1.744, and for this one it's 4000 divided by 910, it's 4.39 meter cube. So just divide the two ratios, total mass divided by total volume. This makes up 927 kilogram per meter cube. Question number 15 says that an electric motor produces 120 watt of useful mechanical output power. The efficiency of the motor is 60%. Which row is correct? We have to find the electrical power input and we have to find the waste heat power output. So efficiency is basically output power over input power. So this becomes 0.6 equals 120 over input power. So we can find the input power to be 200 watt. And we know the input power, we know the output power is 120. So the waste power is the difference of them. So 200 minus 120 is 80 watt. So D is the appropriate option. Question number 16 says that a fixed amount of gas undergoes a series of changes to its pressure and volume. In two of the changes, no work is done by or on the gas. In one change, work is done by the gas on its surrounding. In other changes, work is done on the gas by its surrounding. Okay, so what's it's telling about when the region when no work is done is this region and this region. When the work is done on the gas, that's this region. When the work is done by the gas, that's this region, because the volume has expanded. Okay, so work done is power pressure into change in volume. Pressure is 1 into 10 raised by 5 pascals, and the volume is 5 minus 2, that's 3, so becomes 30 joules. So C is the appropriate answer. Question number 17 says that an object traveling with a speed of 10 meters per second have kinetic energy 1500 joules. The speed of the object is increased to 40 meters per second. What is the new kinetic energy of the object? You simply have to make a proportion that kinetic energy is directly proportional to velocity square. So by using simple proportion, you can say that kinetic energy is equals to 1500 into 40 square over 10 square, which becomes 24,000 joules. So that's the new kinetic energy. C is the answer. Question number 18. The engine of a car exerts a force of 600 Newton in moving the car 1 kilometer in 150 seconds. What is the average useful output power of the engine? Simply apply P is equals to force into velocity. F is 600 Newton and velocity. We have the distance, we have the time. 1 kilometer, 1000 divided by 150, that's the velocity, and just put in the values and it becomes 4000 or 4 kilowatts. B is the appropriate answer. Question number 19 says that an extension graph for a spring is shown. What is the spring constant of the spring? F equals K is the formula, Hooke's law, and K becomes F over E. So F is 6 divided by 15 into 10 raised to negative 2. So this becomes 40 Newton per meter. D is the appropriate answer. Question number 20. A wire is extended by a force. The graph shows how the extension of the wire varies with the force applied. Initially a force W gives an extension D. The force is then increased to 2W. This increases the extension to 2D. Which area of the graph represents the work done by the force when the force increases from W to 2W? You just have to realize that the area is taken along the y-axis. That the extension for finding the area, extension axis is taken. So extension axis is along the y-axis. So just find the area along the y-axis when the force has increased from W to 2W. So it becomes D to 2D. So that area, corresponding area, is this one that I have marked, SRMT or TMRS. Okay, so D is the appropriate answer. A transverse wave on a rope has wavelength lambda and period t. The graph shows the variation of the displacement of the particle of the rope with distance in the direction of the travel of the time at t is equals to 0. A particle x is labeled. Which graph shows the variation of the displacement of the particle with time t? So you just have to realize that when this wave moves to the right, the particle x moves to the left. So if it moves complete wavelength, the particle x would move just like this. First it would move downward, complete half wave, and then it would move upward, complete half wave. Okay, so 21, the answer is C. See, it moves downwards and then it moves upwards completely. So C is the appropriate answer. Question number 22, it says, which statement about all types of transverse waves is correct? They all have the same speed? No. They all have vibrations that are parallel? No. They are also transverse waves, and they are also longitudinal waves, so they do not have same. C says they can all form stationary waves. Yes. They can all travel through a vacuum. No. Sound wave cannot travel through a vacuum, so C is the appropriate answer. Question number 23 says that source S emits microwave with constant amplitude. The microwave hits a metal screen P and are reflected. The stationary wave is formed between S and P. The wavelength of the microwave is much smaller than the distance between S and P. A detector Q is moved at a slow constant speed from S to P. What happens to the amplitude of the signal detected by Q? Now, the signal detected by Q, because there would be several nodes and antinodes formed in between, so at antinode it would be a maximum amplitude, at node it would be a minimum amplitude, so it increases and decreases regularly. Okay, so 23, it's B. Question number 24 says a siren of a moving police car emits a sound wave with a frequency of 440 Hz. A stationary observer hears sound of frequency 494 Hz. The speed of the sound in the air is 340 meter per second. What could be the speed of the direction and movement of the car? Just write the formula. Observer frequency equals stationary frequency into observer velocity divided by observer velocity minus stationary velocity. Over here, the observer velocity is 494. The stationary velocity is 440. Observer's velocity is 340 and stationary velocity is to be found. So Vs is 37.17, and because the frequencies have added up, have increased, so it's moving toward each other. So 24th, it's A, 37 meters per second directly towards observer. Question number 25 says an electromagnetic wave have a wavelength of 138 picometer in a vacuum. To which region of the electromagnetic spectrum does this wave belong? That's 138 picometers. Picometer is 10 raised to the power negative 12. Now 10 raised to the power negative 12, 138 into 10 to the power negative 12 is 1.38 into 10 to the power negative 10 meters. So that region can belong to X-rays and can also belong to gamma rays. Because gamma rays are not in the option, so X-ray is the appropriate answer. Question number 26 says that two wave pulses are traveling towards each other on a long rope. The pulses have the same amplitude and the wavelength and are traveling at a speed of 0.5 meters per second. The diagram shows the rope at time t is equals to 0. Which diagram shows the rope at time t is equal to 3 seconds? At time t is equal to 3 seconds, we have to find that what would the graph look like. For this graph, that's two complete periods. Consider this point, starting point, which is 4. Now we will consider using the formula distance equals velocity into time. Velocity is 0.5, time is 3, So 0.5 into 3 is 1.5 meters. So this point after 3 seconds would move to 4 plus 1.5. This is 5.5 over here. What about this point? 8. It will move over here, but how much? X equals velocity 0.5 into time 3 seconds. So it is 1.5 meters. So this would be 8 minus 1.5. So this would be over here 6.5. So that both waves would make 2 periods here. This also would make 2 periods here, and they will be in phase. Okay, so what would happen? They would add up, constructive interference, amplitudes would add up, and this whole region over here and over here would be 0, and this region they would add up with double amplitudes. So C is the appropriate answer. Question number 27 says that water wave of wavelength lambda are incident normally on an obstacle with a narrow gap. The width of the gap is equal to lambda. The wave from the gap emerged over an angle theta as shown. The gap is slowly widened. Which change, if any, occurred to theta and to the wavelength of the emerging waves? When the gap width is larger than the wavelength, the wave passes through the gap and does not spread out much. So if it does not spread out much, the theta will decrease. Because you see here, theta represents the spread. The smaller the spread, the smaller the theta. So theta decreases and the wavelength of the wave remains the same. Question number 28 says that a light of wavelength 720 nanometer from a laser X is incident normally on a diffraction grating, and a diffraction pattern is observed. Light from laser Y is also incident normally on the same grating. The third order maximum due to laser Y is at the same place as the second order maximum due to laser X. So that means that their spread, the theta, the sine theta is same. What is the wavelength of the light from laser Y? What you can do is you can say that sine theta of X equals sine theta of Y is equal sine theta. For X, sine theta equals 2 into 720 nanometers divided by D. And for Y, you can say that D sine theta equals 3 lambda because it's n lambda. The order is 3. So lambda, computing lambda, here we get 480 nanometers. So A is the appropriate answer. Question number 29. Monochromatic light of frequency F is incident on a diffraction grating of line spacing D. The speed of light is c. Which expression can be used to determine the highest order of intensity produced by the grating? So maximum intensity is when theta is 90 degrees. So sine theta is 1. Sine 90 is 1 basically. So that would reduce the formula of diffraction grating to n equals d over lambda. So after this, lambda could be further be substituted by v is equals to f lambda, or c is equals to f lambda, speed of light. Lambda would equal c over f. So putting c over f over here, we will get n equals df over c. So that's it. Do not forget to like this video, share this video, and subscribe my channel. And also do not forget to press the bell icon so that whenever I post a next video, you get the notification as soon as possible. Thank you.